this is the beginning of 1.1. We're going to be using the foldable that we created in class. If you weren't here for that, you just take your paper and fold it hamburger style, which is the fat overlay, and then you fold it hamburger style again, and then hamburger one more time. So it's 3 hamburger folds, which would be 1, 2, 3. You've got your foldable, and now we're just going to put notes inside of this. We started by talking about domain, and that's an Algebra 1 vocabulary word that we remember are all the x values. It is the x variable if we're talking about domain. What you want to remember is domain has the 2 letters IN right there, and x, the x values can be called domain. They can also be called the input. Again, you've got your IN, or they can be called independent. And this is all vocabulary, just stuff we need to know that we're reviewing. So if I talk about the x values, you say domain instead. I could say input or independent. All of that mean the x variable. So domain by definition is the set of all x values for a function. And if this is quick, you're not getting it written down, feel free to pause it so that you can write and then keep going. The opposite of domain is range. And since it's the opposite, it's not the x values, it's the y values. The opposite of y values, range, is domain. The opposite of input would be output. And the opposite of independent is dependent. If you can memorize these, you don't have to memorize this side. They're just the opposite every time. Same definition, it's the set of all y values for a function. So, 2 vocabulary words. We're going to be working on domain and range more a little bit later. Right now we're going to focus kind of on a number line and writing down the information we get from that. I could have 50 cents in my pocket, and if I asked you what does that mean I'm carrying, you could tell me 2 quarters. You could tell me 5 dimes. You could tell me 10 nickels, 50 pennies. Different numbers of coins, but all of them equal 50 cents. In these 3 spots, we're going to write 3 different notations. They look very different, but they all are going to represent the exact same thing. So it's just 3 different ways of giving me 50 cents, these right here. And that's going to be what your first quiz covers. So the first notation is inequality notation. This is your first notation, not extremely difficult. What's going to take you a few minutes more is actually writing this stuff down, just because it'll take a little bit. We're going to make a number line. Again, if this is quick for you, pause it so you can get it written, and then you can keep going. I'm going to use a highlighter to represent what I'm doing on this number line. I'm going to have an open circle at -3 and a closed circle at 1, and I'm going to connect them. I used a highlighter. You can use whatever you want. Colored pens, pencils, it doesn't matter. You can just use a regular pencil, as long as you can tell what that says. Now, here's the deal. This is a number line. It looks like the x-axis, and I have to represent what numbers are on this number line. Well, according to the number line, I could be 0. I could be 1, because it's closed in. I'm not allowed to include -3, so I can't be -3. I can be -2.9999. I can be -0.5. I can be 0.95. So the problem is, I don't want to write every number that I'm allowed to be on this number line because I'd never end. There are so many decimals in here. So I'm going to write it in inequality notation. I read from left to right, always. Math works the same way. I'm going to go from the left to the right. So I'm going to put -3, I'm going to put 1. Left number, right number. This is the x-axis, so x goes in the middle. As long as you do that, smallest number on the left, largest number on the right, your symbols will always open to the right. No question there. always open to the right. Always, always, always. If you put 1 over here, you've now messed up the problem and you will get it wrong. You must go from left to right. However, here, I'm equal. That means equal. Over here at -3, I'm not equal. So in our notes, we're going to say an open circle is not equal, which means that it's not included. This is not a number that you may be according to the number line. I'm not allowed to be that number. Goodness. It doesn't want to work. That's included. Okay? For a closed circle, which we have at 1, we are equal. That means that we are including it. Pen doesn't always want to write. Okay? So very clearly here, if I were to ask you, am I allowed to be -4? The answer is no. Am I allowed to be -3? According to my notation, no. It's not equal. But this is a boundary, so it starts right after -3. So that could be -2.9, repeating forever and never ending. And maybe that number. That's allowed. Okay? On this square right here, we're going to actually do 2 number lines. So I'm just going to divide this in half so that you know you're going to fit 2 number lines in here. The first number line that you're going to draw is going to go from -1 to 4. And we are definitely going to make sure that we close in at 0, close circle, closed in at 3, and highlight in between. Again, you don't have to use a highlighter, totally up to you. We're doing the same inequality notation. So like I said, we start on the left and we go to the right. So we're starting with 0, we go to 3, we put x in the middle. Now, again, as long as we go left to right, our sign's always open to the right. Always open to the right. And I look and I have closed circles in both places. Closed circles mean equal, so I better add an equals in there to let them know. So I'm allowed to be any number from 0, including 0, all the way up to 3, including that. So I can be 0, I can be 0.1, I can be 0.11111, I can be a lot of different numbers all the way up to the whole number 3. The second number line we're going to put there is going to start, kind of a bigger one. You want to start at -2, but we're going to count by 2's. So we're going to go -2, and then 0, and then 2, 4, 6, 8, 10. If you don't fit all those on there, it's fine. You really need to make sure you get to the number 6. That's it. Okay, again, I'm going to have an open circle, so really important, this is open, and I have highlighting going with an arrow on it. Ooh, what does that mean? Okay, this is important. This is very important. Remember, I start at the left and I go to the right. If you needed to draw this, pause it, draw it, and then hit play again. I'm starting at the left. Did you see that arrow? It means it's going on forever, never, 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 never. So where am I starting? There's no, it's not stopping. It's never ever stopping. So where do I pick to start? Way out here. It's called negative infinity. This is an idea. Infinity is not a real number. I can never count and get to infinity. That doesn't exist. So it's an idea that you're going on forever. And on the right, I'm putting 6. Okay, so I don't have a starting place. It's going on forever, which negatives are out here, so it has to be negative infinity. Positive infinity is out here. So this is negative infinity. I don't have a starting place. It just keeps going. I stop at 6. Remember, x goes in the middle, and my signs always go to the right. Always. Always, always, always. Now, hopefully that makes sense. I came from negative infinity because there is no start. It's just coming from forever. Negative forever, and I'm stopping at 6. Not equal at 6. You cannot equal negative infinity. Is not a real number. There is a shorter version, and this is generally how we write it. I will accept this. This is perfectly fine. But generally what we do is we say just x with the number. So I would chop off this portion. I would say x less than 6. That is the less than symbol. If you look at 6, it is less than, because 4, 2, 0 are smaller. So x less than 6, this is generally how we'd write it. because it's faster, it's simpler, and we're done. Okay? That is inequality notation. The good news is the next notation is almost identical, but it adds a couple things to this notation right here. It adds a couple things, nothing major. So we're going to do the next notation now. It's called set notation. It's got a short name, but it's longer to write. Kind of frustrating, but that's just the way it is. The first thing that we need to know for set notation is that, I don't know how to draw these very well, but on the computer you get these brackets. They're called brackets, braces. We're going to call them brackets. Okay, and then we also have this random line. And I don't want to write it here. I'll write it elsewhere. So I'm going to draw this. Actually, I'm just going to draw an arrow. That number line right here. I guess I can draw it for you guys, just so that we know. So we're going to put -3, 2, 0, 1, 2. I'm going to stop at 2, even though that one stops at 3. I ran out of space. And when I draw this one, again, I'm doing the exact same one, so you can just draw an arrow. You don't have to redraw this, up to you. That exact same number line. I know that I start, according to this, at -3, and I go to 1. That's not the question. I know how to read this now. It's about what does the notation look like. Here's the big difference. It looks exactly the same as this, so I'm going to write it down, -3, x. It looks exactly the same so far. So far I don't have any changes. You're going to put this big line right here. I'm going to draw a little arrow. That means such that. It's weird, but that's what it means. Okay? You're going to put an X right in front of it. So it's going to be X such that, and we've got the information. And then you're going to put the things I can't draw, the brackets. So this is what set notation looks like. It's different than inequality only in the braces, the line with the extra variable. It literally moves from the left to the right. Signs go in the same way. So it's X, this is read X such that -3 is less than X, which is less than or equal to 1. People don't like this one, and the reason they don't like it is all this extra stuff. That's the only difference, though. You're going to take all of this, drop it right in, and you're good to go. So I'm going to give you 2 examples in this other box, just like last time. So the first one I'm going to do on that second half, and there's a reason. I'll explain that in a second. I'm going to go -3 to +2. Okay. Again, pause it if you need to so you get your number line drawn. We're going to be open at -2, closed at 1, and we're going to connect. Alright, like I said, set and inequality are identical. So I'm going to start on the left with -2. I'm going to go to the right at 1. X goes in the middle, and my signs go to the right. I'm not equal, just like over here, open circle, not equal, closed circle, I'm equal, so I need to add it. This is inequality notation, though, and I need it to be set. So I need to put my bracket, I need to put my such that, that's what that line means, X, and my bracket. I'm terrible at drawing those, I'm so sorry. On the computer, they're much prettier than what I'm drawing. Okay, so that's the addition. Bracket, X, such that, close it with a bracket. Okay? Now what I want to do is I want to do this one again in set notation down here. So I'm just going to draw an arrow right here. This is the number line I'm referring to. And in this number line, remember we started at -infinity, we went to X, and we went to 6. Left to right, went from -infinity, from negative forever, to 6. I put my such that, I put my X, and I put my brackets. Now, this is why students like this version better. It's simpler, it's faster. I would literally say bracket, X, such that, X is less than 6, and I'm done. Okay? Simpler, faster. So that's how you put the shortened version in. You drop it in, you throw your such that, X, and your braces, brackets, whatever they are. Okay? That's set notation. Set and inequality are almost identical. This has a few added symbols. That's it. So the last notation, which is really everyone's favorite, this one is called interval notation. That's an R, sorry. Interval notation. Everyone loves this one because it's short, it's sweet, and you are done. Here's what you need to know about interval notation. A couple of things. One, we use parentheses. These are parentheses. Okay, those are parentheses. We use them when we want it to be not equal. Not equal. Now, what you need to remember, not equal means it's not included. So we need to say not included. And remember, we're not included, we're not equal up here when we have a, so this is for open circles. I can't spell today. Open circles. Okay? Now, what about when we have a closed circle? What are we going to use? We're going to use, these are really brackets. And they're not hard to draw for me, thankfully. So we've got brackets, which means equals, which means included. So we're equal, we're including when we have a, this is closed circle. Okay? Those are the things you have to remember. Again, you get to use your notes on your quizzes, so make sure you take good notes. I'm going to draw 2 number lines over here for us to practice, and then the rest of the practice comes straight out of class, out of your book that we will take the pages out. We're going to start at -5. We're going to go to +1. So -5, -4, -2, -1, 0, and 1. Okay? Again, if you're still drawing that number line, you go ahead and stop the video. We're going to be open at -4. We're going to go up to -1. Closed. And we're going to color. Now, this is why students like this better. The way that you're going to write interval notation is going to look just like an ordered pair in math. So you're going to write -4 on the left, comma, -1 on the right. Literally, that's what you're going to write. The first number on the left, comma, last number on the right, comma. Then you're going to decide, am I open or closed circle? I'm open at -4. Open circle gets a parenthesis. I'm closed circle for -1. Closed circle means bracket. So what I like to say is I'm giving this number a hug. I'm including it. I'm giving this number a side hug. I don't really care to give them a real hug. They're just kind of, we're faking it. Not included. Okay? That's how this works. It is literally that simple. People love this version. Okay, we're going to draw another number line. And this is interesting. We're going to count by 0.5. So 0.5, 1. 1.5, 2. 2.5, 3. That's enough. Okay? We're just counting by 0.5s. You haven't done that in a while. Stretch your brain. We're going to be closed circle at 0.5. And we are going to go on with an arrow. Okay? So, in order, remember, we start at the left. 0.5, comma, right number. When am I stopping? Well, according to that arrow, I'm never allowed to stop. So what number is out there in Never Never Land? That's infinity. Positive infinity is out to the right. Okay, so 0.5 has a closed circle. Closed circle gets the hug. Give them a hug. Include them. Infinity is not a real number. It doesn't exist, and I'm not allowed to be equal to a number that doesn't exist. So I'm going to give it a fake hug. Just a little side hug. Okay? Those are your 3 notations that we are going to practice in class, and your first quiz comes over this information right here.